So, you say, you're a physics student. What's all this quantum stuff about? As said physics student, I would probably reply something along the lines of death by 8 o'clock lecture, and having one's brain slowly turn to mush as you realise the crushing reality that you will never truly understand quantum mechanics. If I'm lucky, this will earn me a laugh, right up until the moment you realise I'm serious. Deadly serious. At which point you will either do the sensible thing, which is run away screaming and believe everything the film industry tells you, or you'll say something along the lines of, yeah, but isn't it like atoms and stuff? Indeed, though atoms are only a small part of it. Quantum mechanics strives to describe how atoms and things smaller than atoms behave and interact with themselves, each other, and energy, and in this way act as the building blocks of the universe and possibly beyond. It also explains certain phenomena that normal physics can't. Like what? Well, Einstein said that light came in little packets of energy called photons, which solved a big problem called the photoelectric effect. Wait, isn't light a wave? You vaguely recall playing with glass blocks and mirrors in physics. Something called diffraction? Or was it refraction? Light is a wave, but you just said it was photons, and I know those are particles. Light's both. It's a wave and a stream of particles. This is wave-particle duality, and it doesn't just apply to light, it applies to electrons, atoms, and even small molecules. But everything's made of atoms, and I'm not a wave, you're not a wave, that cat is definitely not a wave. Scientists don't really know at what point wave-particle duality stops, or even if it does stop, but because you are very big, at least compared to a photon, you have a large momentum, which means your wavelength is minuscule, so it's pretty much impossible to test your wave-particle duality. So is wave-particle duality like Schrödinger's cat? That was dead and alive at the same time, just like light is a wave and a photon. Sort of. Schrödinger's cat is a thought experiment used to illustrate the weirdness of something called quantum superposition. This is the idea that two quantum states added together equal another quantum state. This also means that until we observe a quantum object, it is in fact a quantum superposition. For instance, electrons behave as both waves and particles until we try to observe whether they are a wave or a particle. The cat is alive and dead. Yes, until we look in the box, we don't know what state of the cat is, if it's dead or alive. So looking at stuff changes what it is. It's more like it narrows it down. It limits which quantum states in the original superposition something can be. I'm not sure I follow. Let's take an electron. At first we know nothing about it and it could exist anywhere. However, the more precisely we measure it, the more we know about where it is or what its momentum is. Unfortunately, Heisenberg's uncertainty principle means that the more we measure either position or momentum, the less we know about the other. Heisenberg's what now? Well, that's a story for another day. A policeman pulls over an electron. Did you know you were going at 80 miles an hour? He said. Great, said the electron. Now I don't know where I am.